Okay, the next part of the lesson, we are going to look at polyatomic ions. So poly means many atoms. So these atoms join together to form a charge, to form an ion. Okay, this table unfortunately is memory work, and the earlier you memorize, the easier your life will get. Okay, so hydroxide formula is OH minus. From it you can see hydrogen, oxygen, so you have OH, the charge is minus. Two atoms chemically combined get a charge. Okay, nitrate comes from the element nitrogen, so N-A-T-E means oxygen is added. So how many oxygen we have to memorize? It's 3 oxygen added to nitrogen, and overall they get a charge of minus. Sulfate, SO4 2 minus, sulfur and oxygen added, 4 oxygen added, get a charge of 2 minus. Phosphate, PO4 3 minus, carbonate, CO3 2 minus. Moving forward in your chemical reactions, whenever you see carbonate, CO3 2 minus, always think of carbon dioxide. When you see carbon dioxide, always think back carbonate. This is always true because these two compounds are very similar. Okay, carbonate will always form carbon dioxide in a chemical reaction. Ammonium, NH4 plus, always think back ammonia formed in a chemical reaction. So you have ammonium, give me ammonia, ammonia will give me back ammonia. Always think of it this way. Okay, ammonia is our pungent gas. You will be testing this gas in the lab moving forward. Okay, so why are these equations important, or why are these formulas important? It's because the nitrate, the sulfate, the carbonate gives us your corresponding strong acids. Okay, so corresponding acid, nitric acid, sulfuric acid, phosphoric acid, carbonic acid. Okay, so using the sulfuric acid as an example, why is the formula H2SO4? Same idea, when you write the equation, acid, your formula is H plus, your ions. Okay, sulfate, memory work is SO4, 2 minus. Okay, so sulfuric acid, do the cross method, bring down the elements. So in this case, your SO4 will look something like this. The whole thing, 4 oxygen, 1 sulfur, has a charge of 2 minus. Okay, and then you do the cross method. So you bring the 2 down, H2, this is 1, you bring it down, no need to write. So you have H2SO4, your sulfuric acid. Okay, so let's practice some examples over here. For example, let's look at this group of ammonium products. Okay, ammonium carbonate, NH4 plus, carbonate, CO3, 2 minus. So again, we can see it this way. NH4, 4 hydrogen atoms bond to 1 nitrogen, overall has a charge of plus. And carbonate, 3 oxygen bind to 1 carbon, overall get a charge of 2 minus. So bring down your formulas, bring down whatever that's inside the circle, and then do the cross method for the charge. So 2, bring it down, 1, bring it down, no need to write. So this 2 on the outside doesn't mean anything, right? So you have to put a bracket. Okay, essentially, I need 2 times of the NH4 plus. Then it will balance out the 2 minus. So the whole thing, I need to have 2 in a bracket. That represents 2 times. Okay. Let's look at another example. Ammonium nitride. So this example over here, look at the name is IDE. So IDE is the ion in your periodic table. Oxygen become oxide. So ammonium, still NH4 plus in the memory work table. Okay, nitride, look at nitrogen is the ion, IDE. So in this case, if you do the reverse method, right, you have NH4, whole thing bracket 3. And this is 1, I bring it down, nothing to write. 3, I bring it down, whole thing I need 3 times. Okay, let's practice this out and we will look at the next part.